Are you ready, kids? Today we're going to get into exploring the ocean floor. I know this is the first video for a few of you, so listen to the verbal cues when I tell you to pause and stop and write a few things down. Please make sure you take good notes. I'm going to put a stamp in your stamp sheet. As always, if you have any questions, feel free to send me a message on Edmodo or send me an email. All right, so when we take a look at exploring the ocean floor, we begin with why to study the ocean. And just a quick little history lesson here. They began studying the oceans really around the 15th century, the 1400s. And they mainly did this for a source of food and also travel to get around. There really wasn't a lot of exploration because people didn't know that there was much beyond the lands of where they already lived. So at this point, the science of oceanography really hadn't been born yet. So the early times, they really just studied the oceans to eat and to maybe get around from one short distance to another. But they did not travel great distances. Not only because they didn't know where things were, but their boats were kind of crude. They couldn't go very far with the boats that they had. But then things began to change, go forward about 100 years or so, for the next 400 years. People began to study the ocean for maps. They started to realize that their boats can carry them further. So really, when we talk about ocean exploration from the 15th century through the 20th century, it was, to make maps, but it was also more of a social thing. It was just a way to find food and travel to get from one place to another. It was never to understand the properties of the ocean. So why do we study the oceans today? Well, there's a whole bunch of reasons why. It really helps us understand how the earth works. Helps us understand, this is a pretty short list, things like the weather. It helps us understand global climate change, so global climates. It helps us understand about the diversity of life on the planet when we take a look at life within the ocean. It also helps us understand the interactions between the oceans and the planet because the oceans cover about 71% of the planet. We use it for food. We use it for a source of recreation. We could add more to this list, but these 6 points here are pretty important when we start talking about the dynamic interactions between the oceans and our weather patterns, our global climates, life on Earth. The fact that it covers 71% of our planet, food, recreation, these things are all important to us. So these are some of the reasons why we study the oceans. So how has ocean exploration changed over the years? Back in the 1500s, when there was all this social exploration of the ocean going on for food and to map out lands and stuff like that, this guy Magellan, he was the first guy to try to circumnavigate the globe. Now, he didn't make it, and what circumnavigate means is that you start here and you go all the way around. You circle around the globe in a boat. He tried to, but he was killed in this battle in the Philippines, this place called the Battle of Macatan. Don't need to know that. Don't worry about writing that down, but you should know who Magellan was and for what his accomplishment was, the first guy to try to circumnavigate the globe. But really, when he went around to circumnavigate the globe, he did it for a lot of reasons that were different from the ones that we talked about earlier. He was interested in what the ocean held. He was interested in what the properties of the ocean was. He was interested in exploration of the oceans and not just using the oceans as a source of food. So then in the 1700s, this guy, Captain Cook, I'm sure you've heard of before, James Cook, he was the first guy to map out the ocean. He got in a boat and he mapped out all the land borders that he possibly could. He made the most accurate map of the land borders within the ocean that anybody had ever made at the time. He didn't get everything, but he made a pretty accurate map. And here we have a continuation of Magellan's work. We have somebody doing work in the oceans that's more scientific than social. So in 1855, the first textbook of the ocean comes out, and it brings about the birth of oceanography. And you already know that that oceanography is simply the study of the oceans. And it goes beyond using the oceans as a source of food. It's looking at the oceans from a scientific standpoint. Make sure you have that down. So after this textbook of oceanography comes around, this ship here, the Challenger, same ship that we talked about with plate tectonics and Harry Hess, this guy went around the world for 3-4 years, something like that, and it made so many new discoveries, something that nobody had ever done before. It discovered thousands of new organisms. It learned about ocean currents. It discovered part of the shape of the ocean floor. But the big thing here is this became a model for future voyages, for future exploration of the ocean floor. So it's a really important ship in the history of studying the ocean. So what does it do? What did it do? Here's some things. It studied the oceans. It went around and studied the oceans for like 3.5 years. So it spent 3.5 years sailing the oceans. It discovered thousands of new organisms. It mapped out part of the ocean floor. And it became a model for future discoveries, for future voyages. And it also learned a ton about ocean currents, or the circulation of the water within the ocean. Make sure you write this stuff down. Now, in the early 1900s, things really began to change. This new invention came out. It was called sonar. And sonar stands for sound, navigation, and ranging. Got to know it. And here's how it works. Basically, you got a ship, and that ship will send out a little signal, just a little sound wave. And that sound wave will travel all the way on down to the bottom of the ocean. And it bounces back, and the boat then receives that sound again. So you've maybe heard this in movies where it's like a ping, it's like ping, and they in like a submarine or something like that. And again, what they're doing is they're sending out a sound wave down to the bottom of the ocean. It bounces off the bottom of the ocean, and then they know how deep the ocean floor is. Why? Because they time how long it takes the sound wave to go from the boat to the bottom of the ocean and then back up. And what that's going to look like is this. If this is the top of the water, and here's the bottom of the ocean, and your ship is right here, and it sends out a sound wave, so it's going to go bing, boom, and it comes back up. And then your boat's over here, and it sends out a sound wave, and it's going to go bing, boom. This time here will be short, and this time here will be longer. Why? Because the sound wave takes longer to get to the deeper depths and to come all the way back up, versus this guy here where it's shallow, where it has less of a distance to go, so it goes down and it comes back up in a shorter time. This helps them map out the bottom of the ocean floor. On Monday, we're going to start a lab. We call it the Box Ocean Lab. We're going to simulate mapping out the bottom of the ocean. And on the box, there's a left side, there's a right side, there's a box number. All this is labeled for you, and depending on your lab group, you'll be working with a different box. And then what we have here, we have these holes that I drilled into the top of the box. And what you're going to be doing is you're going to be taking this round ruler, this wooden dowel it's called, and it has centimeter marks on it. So here's 1 centimeter, 2 centimeter, 3 centimeter. And you're going to be placing this ruler into the drill holes. And you're going to be measuring how deep the ruler goes down. So this ruler here, if we take a look, it's in the hole there. It goes down. Here's 10. One below it's 9. So it goes down 9 centimeters. These are all in centimeters. So this is what you're going to be doing on Monday. What are you going to be doing with this information? Well, after you figure out how deep the ruler goes for each one of the holes in the box, then you're going to go ahead and measure the distance between the holes on the box. You got to make sure, let's go ahead and keep it consistent, that you measure from the left side of each one of the holes. You measure the distance between the holes from the left side of each hole. We'll review this in class on Monday, but this is just a little preview so you know what's going on. So what are you going to do with all this data? You're going to take it and you're going to put it into a spreadsheet online, onto a Google Docs spreadsheet. And the really nice thing about that is this, is all you need to do is just type the numbers in. Here's the distance column right here, and here's the depth column. So the distance is the distance between the holes. The depth is how far down that round ruler goes. And once you plug those numbers in, and I just put in some fake numbers here, so the distance of 2 centimeters, 2.5, 4, and all the way down to 11, and then a depth of 0 centimeters, 1, all the way back 1, 2, 3, 3, 2, 1. And what it's going to do is it's going to convert these centimeters into kilometers and meters for you automatically. So you don't need to do any conversions. So we're going to have these numbers here that represent distance between the drill sites, or the holes in the box, and the depth that that ruler went down in meters if you were actually mapping out the bottom of the ocean floor. And then the real beauty is when we take a look at the bottom of the sheet, we're going to see that we have box 1 graph, box 2 graph, 3, 4, 5, 6. And after you put your data in, you're going to click on the appropriate tab for your box. So in our example, we were looking at box 7. So I would click right there with my mouse. And after I do, it's going to show you a graph. It's going to show you a graph of your map, of your plotted points. And then all you'll need to simply do is trace your line and take a look at the feature that you have on the bottom of the ocean floor. Pretty cool. So you're going to be mapping out a segment of the ocean floor for your group and your group only. And then the beauty part is this is just for one box. We're going to take this and we're going to match them up with all the other groups, and we're going to have a complete profile of the ocean floor. All right, that does it for this presentation. Remember, if you have any questions, please feel free to send me a message on Edmodo or send me an email. Make sure you take good notes. I'm going to check stamps. I'm going to check your notes on Monday for a stamp. Have a great weekend. Go sledding. Go Hawks.